Hello. In this video we're going to look at how to label two proportion problems. All right, so we're dealing with our yes-no traits across two populations. So the same yes-no trait across two populations, and we're comparing them. But in this video we're just focusing on how to label. All right, so let's say in example 1 we have a travel agency wants to market to target audiences more effectively. The agency takes random samples and finds that 56 out of the 142 people aged 40 to 75 traveled abroad in the past year, while 35 out of the 126 people aged 18 to 39 traveled abroad in the past year. So traveling abroad in the past year is the trait. It's the same trait across both populations, and it's a yes-no trait. You either did or didn't travel abroad in the past year. And the two populations are older and younger, shall we say. This is the older population, 40 to 75, the younger population, 18 to 39. So we'll say older, younger, right? So when I go to make my info box, oops, what I'll do is I'll say, I see, older, and then younger. Okay. And what I need to pull out are the sample sizes and the sample proportions. So here I'll use subscripts very carefully to identify which population they come from, the information comes from. So if the sample size for the older people is 142. The sample size for the younger people is 126. The sample proportion for the older population is 56 out of 142, which is 39.4%. For the younger, you get 35 out of 126, or 27.8%. Now, I go ahead and leave them as decimals because that's how you're going to work with them when you're actually calculating things. So there's my info box. All right, let's try another example. And here you may want to pause the video and go ahead and go through the example and see what you get. Okay. So a veterinarian association wanted to know if cat ownership is preferred by one gender over another. Among randomly chosen people, 35% of the 2,346 males said they chose to have a cat as a pet, and 42% of the 1,691 females said they chose to have a cat as a pet. So what we have is males and females. Right. Those are our two categories for our info box. And those are the two populations. So what you have then is, you already know the trait is whether you have chose to have a cat as a pet. That's the trait. It's a yes-no trait. And you have males versus females. So here's your p-hat males. Right there, 35%. Here's p-hat females. And there's your N sub F. I'm sorry, M. The sample size for the males and sample size for the females. So what we have then is sample size for the males, sample size for the females. That's going to be 2346 here for the males and 1691 for the females. The proportion of males who have cats, it's 35%. The proportion of females, sample proportion for females who have cats is 42%. So that's my info box. Okay. And last example, again, you might want to pause the video, give it a try. So environmentalists want to know if there has been an increase in climate change believers. Random samples were taken in both 2000 and 2010. In each decade, people were asked, do you believe climate all over the world is experiencing significant changes? In the year 2000, 360 out of 1,027 people said yes. In 2010, 667 people out of 1,150 people said yes. So the trait is whether you believe in climate change or not because you said yes. So technically saying yes is your trait, but we understand that it's really that you're a believer versus not. And then your two populations are the ones in 2000 and 2010, right? Okay. So when you go to construct your info box, you have the year 2000, the year 2010, And then what you have is the sample size for 2000 versus the sample size for 2010. So here in 2000, 1,027 people were asked the question, and then the sample proportion was 360 out of the 1,027, which is 35.1%. Versus in 2010, you had 1,150 as your sample size, and sample proportion was 667 out of 1,150, or 58%. So there's my info box. Thanks so much for listening.